So, so I found this problem and I liked it for a couple of reasons. It's a geometry problem, and it deals with the circle, and eventually it ends up dealing with the triangle as well. So I'm gonna have y'all pause it and try it out first, and then let's see how you did. We're in the XY plane, and we have a circle that has a center C. So, and then it gives us the coordinates as h comma k. And then it says points A and B lie on the circle. So somewhere actually on the circle. Point A has coordinates h plus 1 comma k plus root 102. Okay. And then angle ACB is a right angle. What is the length of AB? Okay. So we got 2 points A and B on the circle. And then I noticed they give us the coordinates of A but not B. So let's just kind of update my picture and then let's talk about it. We got the center and then point A. Notice the x coordinate says h plus 1, and then the y coordinate says k plus root 102. Now, obviously, I don't know what that is exactly, but I'm going to use a little bit of an estimate here. And I know that 102 is really close to 100. So this is roughly the square root of 100, which is 10. So essentially what I'm thinking is from the center, I'm going to go to the right 1 and up roughly 10. And of course, on the SAT, this doesn't have to be like perfect, at least somewhat approximate with it. Okay. And then they tell us that the angle between AC and B is a right angle. Okay. So like I said, they don't give us the coordinates of B, but if I were to make a right angle ACB, that can at least tell me where point B is. And then of course they tell us that that angle is a right angle. So they're asking us for the length of AB. So I guess it makes sense to draw a line from A to B. And on the test, of course, this should be screaming right triangle. Distance from A to B. When I first saw this problem, I thought use distance formula, obviously, but we don't have the coordinates of B. So my first thought was, okay, if I can somehow get the coordinates of B, then we'll be good. But what I then realized is that if you look at between A and C, they do give us both of those coordinates. So I can find the distance between those. I can find that distance using the distance formula. So I do have to know that. And then because it's a circle, I know that CB must be the same distance. So some people are going to think from there you can use Pythagorean theorem, which is true. You can do that and get the right answer. But one shortcut that I feel like would be really useful is if you notice that both of these legs right here are the same. And so what that means is these angles are also the same, making this a 45, 45, 90 triangle. That can be a big time saver because I kind of jotted off to the side and they actually give you this on the reference sheet. But for any 45, 45, 90, all the sides are related. So your two legs are going to obviously be the same length. And then your hypotenuse is whatever that leg is times the square root of 2. So if you know that, or if you pick up on that, then you can save like, I don't know, however long it takes you to do Pythagorean theorem. So the plan is now, I can use distance formula to find AC. That'll be like my X, so to speak. And then I basically just got to take that value or that distance and multiply it by the square root of 2. And then that'll be my answer. So part of why I like this question again is because you basically have to know the distance formula. And for anybody who doesn't, I can jot it down really quickly, which on the test, I recommend if you need to, jot it down yourself as well, because once you have the formula, you know, you just replace letters with numbers. Okay. So I admit this problem is hard if you don't know distance formula, in my opinion. That is the square root of what? X2 minus X1. So what I'm going to do, I'm just going to choose to let point A be my X2, Y2, and then I'm going to let point C be my X1, Y1. It would have worked the other way around. I just had to pick a way. So, and then on the test, I'm thinking I got to take this X coordinate and subtract H. If you need to write it out, then write it out. But some people can just see that and see that the H's are going to cancel out. So I'll write it out for now, but just notice that's like another time saver. So my first X coordinate will be H plus 1. And then that's like my X2. And then I'm subtracting X1, which in my case is H. So I'll go minus H. That whole thing is squared plus Same thing for my y2. So my y2 is going to be k plus root 102 minus my y coordinate, or my y1, which is just k squared. So essentially whatever this comes out to times the square root of 2 should be my answer. So if I just simplify this down, here you can see what I was talking about. If I got a positive h and a negative h, those are just going to cancel, leaving me with 1 squared, which is just 1, plus k's cancel in the same way. Square root of 102 squared. Hopefully you know the square root and the square cancel each other out. So that's just 102. So whatever root 103 is times root 2 will be my answer. And so obviously you can see that that's a, but if I need to write it out, I'll say that AB is going to be equal to the square root of, what do we say, 103. According to special right triangles, we're going to multiply by root 2. And that is literally the square root of 206, which does correspond with answer choice A. So I like this question a lot as well because Desmos can only probably help you out so much. Because I know you can probably type it into the formula, but you still got to know either to use Pythagorean theorem or know that special right triangles relationship. So I don't know. I thought this was a pretty good one. Comment and let me know how y'all did. If y'all want to see more SAT videos like this, make sure to like and subscribe. And with that being said, I'll catch y'all in the next one.